Hey there, everyone. Welcome back to our series of lightning talks on our Shrubwise data challenge. Today, I am joined by Scott Pokswinski. He is the Director of Fire Science Applications at the New Mexico Institute. Scott, thank you so much for joining us.
Thanks for having me, John.
All right, let's jump right in. Tell us about the IntELiMon system, what it does, how participants might use it.
Yeah, so the IntELiMon system is essentially a monitoring program first and foremost. Um, but it's a monitoring program that also collects really useful data for research. So the idea is to hand a firefighter or a land manager or somebody who's wanting to track change or status in for whatever it is they have a handheld, well, not a handheld, a small TLS scanner that you can put in your hand, go out into the woods, push the button, upload the data, and have it all processed into useful metrics. And those metrics can include things like tree diameters and numbers of trees and tree maps, fuel characteristics, just like habitat quality for a certain specific species, whatever it is that we can model, that we can build, essentially use the outputs from these to build predictive models for, or use some of the raster-based products to, build a shrub list or look at canopy density and things like that. So it's really kind of a multi-tool that someone can go out and collect data in less than a minute and then transfer that and rather than do it the old-fashioned way, which was stretching tapes, measuring shrubs, trees, and writing that up on a data sheet and putting that in the file cabinet till someone gets money to analyze it, and then do all that kind of stuff. So it's essentially kind of a taking a monitoring program and making it a lot more accurate, quantitative, and efficient.
Yeah, we talked with Kayla Johnston, who goes out and measures the trees sometimes by hand, which even more time intensive, even more expensive. And if the participants haven't had the chance to see what the output looks like when someone processes it into a picture, you've got to go check it out. It kind of feels like you're standing in the middle of an orb of forest, and what you would see as a person standing in that spot has kind of been rendered for you with almost like a video game kind of sense to it. You can really see the forest, which is pretty awesome. But in terms of the actual metrics that you're able to gather from IntELiMon, what are the metrics that come from that data that you think would be most useful for measuring shrub fuels?
We output first of all a shrub list, and when I say shrub is interesting because it has it conjures up a structural idea of something. It's usually a type of tree or woody vegetation, right? And that could be of various sizes, but generally not single stem, tall and skinny, right? So it's really kind of more of a qualitative thing. So from our perspective, especially when we're characterizing for our use in fuel layers, shrub-like objects are more what I say that IntELiMon can do.
Oh,
Things like classifying lumps of fuels in space, and some of the things that we do once you take all of those tree stems out of the scan and then you crop it to 0 to 3 meters, which is 9 feet, so kind of a maximum height there on the shrubs that we calculate. We can then use sort of these airborne lidar algorithms to then like lay a cloth over it and create a raster of what's left. And usually what's left are these like lumps
mhm.
of shrub-like objects. And some of those are actually just like lower branches of trees, but to fire, it doesn't matter, right? It's the continuity of fuels, the size and the amount of fuels that we're trying to characterize. So things like I think it's even called, the raster is even called like the fuels raster, but it's really a bunch of shrubs. We also take that raster and we analyze it. We use sort of, like I said, these ALS algorithms to find these lumps that would be like the tops of trees that you'd use for airborne LiDAR canopy. And then you can get a shrub list out of that, which would include the centroids X and Y coordinates. So if you have a whole list of all the shrubs, their X and Y coordinates of where these lumps of fuels exist, you can also kind of derive a spatial arrangement of those fuels. Are they clumped? Are they evenly spaced? Are they random, right? Those would be key for doing things like, oh, scaling up, right? So if you had an algorithm that used those locations, but then not only that, but sort of the size. So we have a convex hull size that's reported in that, and also the height of that shrub. So you get, if you think about it as a pure shrub, you might get weird numbers like all the shrubs in this were 2.999 meters, but that's just saying there was a bunch of shrub-like objects that went to the top of that layer. So there's some limitations that they're not maybe always true shrubs, which is why I kind of characterize what IntELiMon does as shrub-like objects. But it also, the metrics file outputs the like standard deviation of shrub heights, or the number of shrubs found. So it has some summary statistics, the shrub distances, the max and min and standard deviation of distances between shrubs. Those also would be useful, I think. So both from the metrics file and from the shrub list that comes out, and then also that fuels raster, I think would be really useful tools coming out of IntELiMon to be able to parameterize some sort of way of building a shrub model.
Excellent. Let's think a little bit now about generalizing in this problem of taking this plot data and extending it out to predict what's in the landscape. What are the challenges that exist there?
So some of the challenges that we have are definitely sample size. That's the thing that comes to mind. If we're parameterizing a model that might have some list of shrubs, IntELiMon each scan has a reach of about 15 meters, so a radius of 15 meters. So you're talking about a little over a tenth of an acre plot. If you're talking about a single tenth of an acre scan and then extrapolating those shrub distances, are we actually capturing the true distribution of shrubs across an entire 300-acre unit, right? Those are some of the challenges. So, getting a representative enough sample is always a problem. That's sort of why we created IntELiMon, for you to be able to go out and just set up a laser and push the button in 30 seconds, you've got a scan. But there's still limitations, if you've got large scale areas to cover, right? So, certain sites I think will be easier than others, because there will be some sites that are much more dense, anywhere from 5 to like 50 scans per burn or per management unit. You're good. Things that are a little less are going to be tricky. But to me, are we able to capture the true scale and range of what the shrubs occur in that little 15-meter radius, compared to, if you look across the management unit, you'll have some spots that are bare completely of shrubs. How big is that, right? So being able to, make sure that you're representative of those is the tricky part.
This is probably a naive question, but as you were talking about there being denser and less dense plots with shrubs, of course, IntELiMon can't see through the shrubs that are closest to it. So is there some way that you attempt to extrapolate from like the average distance of the shrub from the unit, how many must lay beyond it to the edge of what IntELiMon could see if it could get that far?
So there are, I believe, I know we do this for the trees. I'm trying to remember if we do this for the shrubs. One of the metrics, and I think we actually output the non-occluded area. So what we can do, because there's occlusion in a single scan, there always is going to be like, what was behind that tree? So the way that we correct for that, at least for the trees, is to then take a look at the DEM. Excuse me, well, not the DEM. We actually classify all of the points that are ground, and we look at the missing pieces of the pie, right? So if you've got a tree or a shrub, you don't get ground right behind it, because so we take that area and we take the total area of the radius. The total area of the possible area, which would be 15 pi r. Yeah. Anyway, squared. But and then we subtract that missing data. Essentially, we create at the, I think, quarter meter scale, 20 or 25 by 20. Yeah, well, maybe it's quarter meter, which is quarter square meter, which is 50 by 50 centimeter. We look at all the missing data and we say, okay, let's correct for occlusion. Now, I believe that we report that occlusion value in the metrics. I have to go and check, but there is a way for us to get it for you and then be able to use that and say, okay, this is how much the area actually is representative of versus not with just saying, oh, there was this many shrubs. I will say that while there is occlusion from things like really dense things like trees, the shrubs are less of a problem. There's usually still the scans are so dense, unless it's like a full leafed out shrub that happens to be like nicely trimmed up, right? Like you would
Yeah.
see it a hedgeway. You're going to get penetration into some next shrub-like objects. So
As long as there's a hole through those leaves,
there's still the
IntELiMon, how
possibility.
far it goes until it hits something else,
Yeah.
that you
So,
build like
so
a
if you,
partial picture, almost like a
yeah,
shadow, right? Like you can see all the parts of that shrub that would be in the light behind it, but the shadowed part you wouldn't see because that's occluded by the shrub in front of it.
and correct. So with the most lasers that we have, it's either anywhere between 12 and a half to 15 million points in that dome. So if you're talking about 15 million times you're shooting through, you're going to get some that
Hmm.
go through holes in shrubs, and hopefully, if they're natural shrubs, right, get some what's on the other side.
That is amazing. All right. What validation approaches work best when you're comparing the TLS derived shrub metrics with field measurements?
Yeah, that's a great question. We're actually doing this for trees right now for a validation effort that for a DoD project. I mean, going out and measuring it the old-fashioned way is kind of the typical way that you do it, and then you do enough of that, and you do replicates. So we talked about what I was doing last week. We were out in the woods measuring trees the old way with three different teams doing the exact same plots and three different scans, so that can look at, okay, how repeatable are the scans on top of each other and how repeatable are our measurements on top of each other, and then we try to reconcile those things, right? um, if that data isn't available, another path is to look at the scans qualitatively on points to pano or something like that. That's what we suggest. Or if you're doubting the numbers that come back, points to pano is a great tool developed by Isaac out of UCSD to go and match those scans up and look at them and say, this said there were like 30 shrubs, but all I see are trees and like little low growing vegetation. you know, my suspicion is what we've done is we've just classified what the branches that are down to the shrub once the stem was removed from. But that's a way that you can validate, right? So you can go and like qualitatively look at those images, those rasters of the point cloud is essentially taking all those points and then splatting that against a raster and visualizing it with RGB. You can see those values or see that qualitatively and do it that way. That's really the best way I would recommend to doing it, without you actually being able to go there and measure them yourselves, and unless you have some data that people have collected.
I want to point out that the notion that having three sets of people, if I understand correctly, go out with an IntELiMon unit and then hand measure the plot, and then you try and reconcile the extent to which each of those now six measurement sets look like each other. Sounds like a massive amount of work, but I'm guessing that the goal is that with enough of those things, the algorithms that process the IntELiMon output become increasingly accurate to the point that we need less validation because we're increasingly confident that what we're getting out of that algorithm from the IntELiMon data is correct.
Yeah, absolutely. It's all about understanding the uncertainty. To what degree can we quantify the uncertainty that IntELiMon's giving us and
Mhm.
essentially the traditional field way of collecting data. Um, and right, that's why you have three replicates, like for even the scans. So, measuring up the tree map perfectly and making sure that that didn't matter who pushed the button. Also, like how far offers my distance and azimuth measurements, and then my DBH, and then my height measurements, right? So the old ways of doing things will have error built in, but you typically don't know what that error is because you only do it once.
Mm.
So that's really what that's about and then the other part of it is then comparing efficiency for us. Like we timed every step of that process so that we can say, this is the effort that went into collecting that data, and then this is the effort of pushing the button and how long it took to do that. So being able to compare, that effort for efficiency, but then also consistency and accuracy, and being able to measure those consistencies and accuracies across across teams then tells you something about the uncertainty of each of those tools.
I think this is one of the reasons that they've tasked me, a layperson, with doing these talks because I came to the skill lab at a point where Isaac Points to Pano was starting to look like a hyper-realistic video game you could drop firefighters into. And so that's the universe into which I came to, these fire sciences. But you had to have years and years of people, decades of people out in the woods measuring trees by hand, inventing machines that would go take these points. And now we've arrived here where we say something like, "Oh, we can't know anything about shrubs in these ladder fuels because they're not easy to characterize with aerial LiDAR scans." But in fact, we are, it feels like the space age compared to what was available to us even a decade ago. Anyway, that's just me being amazed, and I think
No,
it's
I mean
useful to
that's a great
contextualize.
point. That's a great point. I mean, for me, like the big advantage of terrestrial LiDAR and IntELiMon over something like airborne LiDAR, which does have the ability in open canopy to see some shrubs, but to a limited extent because you have the occlusion from the top this time,
Right.
is that the way that we interact with shrubs and we understand shrubs is through our point of view, right? So my perspective is lateral, and and looking up, looking across, down and up, and whereas airborne LiDAR is purely there's a little bit of it, like they fly it at a slight angle, like something like a 15 degrees off of
Oh,
nadir, which
yeah.
is so you're capturing some of that, but for the most part, it is straight down, and you can only see the tops of things, right? So us understanding vertical structure, which is kind of the key thing that shrubs are going to help us understand, you know, nothing is better at it than our perspective, right? So that's why the TLS is the unit for that particular, for the tool for that particular job. The problem then lies with occlusion,
Mhm.
area of, how what the it's tough to scale up because just has a single small footprint. So
Excellent. Well, before we go, do you have any advice to our participants about how to go about this challenge?
So one of the key, more powerful things about IntELiMon is its ability not only to look at things from an object-based approach, but also from there's 200 and some structural, around 250 structural metrics that come out of that. One of the ways that we do a lot of the work that we do is not necessarily saying this point is shrub point, this point is rock point. We do predictive models. And so if you can tie structure to some of these outputs, it may be also useful. And those structure metrics, like I say, come out, and some of those are direct. Some of those 250 metrics are things like I said, max shrub distance or mean shrub height, or uh, you know, open total canopy openness, or things like that. But some of them are things like the kurtosis of points hit at the height strata of between 1.5 meters and 2 meters, right? So there's all sorts of crazy numbers that come out of IntELiMon. There's a lot of power in those structural metrics. And sort of the way that we get at that is like points that, we know where the points come out of the point cloud, how far it goes. Does it continue on and come back? We keep total track of all 15 million of those points. So don't lose sight of the power of those as potential. I may be throwing people off to go down this road, but like there's a potential there to characterize shrubs in ways, and other things in ways that we've never thought of doing before, breaking down the point cloud mathematically.
Yeah, don't throw anything away. I mean, I think this is part of the, I guess, philosophical advantage of these kinds of deep learning approaches, right? Is that things that we would not think of as being connected, even in a secondary or tertiary way to the thing we really want to know, could reveal patterns that a machine that can plow through these numbers so fast will reveal to us in a way
Yep.
that becomes intuitive once we see the pattern. And that is, I mean, just the mystery of the way that some of these algorithms work, I suppose.
Yeah, yeah. Just to give a really quick example, we have a paper in review that is predicting soil metrics. Mineralized carbon, nitrogen, and it's all tied to doesn't the laser isn't penetrating the soil and measuring the nitrogen, the mineralized nitrogen or the carbon. It's pulling information from the structure that ties to the nitrogen cycle or the carbon cycle. So being able to build those predictive models indirectly, we get really really high R squared values and low RMSEs. So that paper is in review. So we're really just sort of cracking the surface of what this tool is capable of. So yeah, when I say, don't underestimate the power of these metrics that might mean nothing to a manager, they can potentially mechanistically link back to some things like shrub, something of interest in shrubs. So yeah, I go down all the avenues as long as you have
Well,
time.
oh yeah. All right, I suppose, yeah. All right. Well, thank you for joining us, Scott. It's really been a pleasure as always. And to everyone watching at home, I will see you in the next Shrubwise video. Thanks so much.
Thanks, John.